All right, let's get this started. So, thanks everyone for joining. This is Stateless Implementers Call number 45. We skipped the last two due to, well, first Devconnect and then some other unavailabilities. So it's good that we're meeting up again after, I think it's been 6 weeks almost. Yeah, I linked the agenda in the chat. So we are going to start with team updates. So whoever wants to go first, the mic is yours.
From my side, I've been mainly working on scaling L1 stuff, trying to write more scenarios on East, also wrote down some scenarios in Spammer to bloat ERC20s, to do some tests related to contract size, contract storage size. And besides that, I'm also working on a new page on the lab, which basically will contain a state analyzer tool to analyze growth and some other metrics.
Nice. Thanks, Carlos. Anyone else?
Yeah, I've been working on the implementation of binary trees in Geth. We managed to produce the executable. We had a conversation with Mario, although he was interrupted, but we had a conversation with Mario in Devconnect where we wanted to use the weld. But yeah, we haven't really started working on that yet. Maybe we can take a few minutes to discuss what needs to be done after that. But yeah, that's roughly what's been going on.
Good, thanks. Anyone else? All right, I guess that's it for team updates then. So this moves us directly to our second point. So the second point is something that I think Carlos had initially brought up, but I think, Guillaume, you wanted to take that conversation up and lead it. It's about code chunks inclusion in the leaf of the binary tree. So to recap, and correct me if my understanding is wrong, is that currently in the current leaf redesign, what we have is the first 128 bytes of the code associated with an account that is included in the basic leaf, the first leaf of the tree. This means that a part of the code is there, and the rest of the code is chunked away and left in separate leaves. This has some advantages, but also some downsides. So the advantage is that you can access, as soon as you access the account, you have those first code chunks, which are maybe the most used, are available there. But the big downside is that if you want to optimize your tree and store contract code that is identical across different accounts, then you need to store it in all these different iterations. Whereas when you have the code fully modularized from the account, then you can store it in a single place and refer to it from the account. So the suggestion here is to move the code completely away from the account basic data, so that it can be offloaded to a separate place where it can be effectively compressed and only stored once for multiple accounts. So yeah, Guillaume, do you want to take it on?
Yes, sir. Great intro. I also made some presentations, so there's going to be a lot of repeats. Sorry about this. Still looking for my window as I usually do. Okay, that should be it. Right. So I just wanted to do some recap, and I apologize because I was stuck in a meeting before, so I hope I finished my slides on time. We shall see. Sorry if there are mistakes. So as a reminder, in Vercol or binary trees, everything, every account item is at its own offset, and we have the basic data, which contains the code size, the balance, the nonce. It's at offset. The code hash is at offset 1. And then you have the first slot, which is at offset 64. And everything in between is reserved for now. And then the slot number 63 is at offset 127. And then for slot 64 and further on, we move to a main storage offset, which I think is 2 to the power of 31, something like this. I forgot exactly the value, but it's a very large value. And so any subsequent slot number will be an offset beyond this big value. And then at offset 128, we have the first code chunk all the way to 255. And then when we reach this thing, you get main code offset, which actually is a mistake. Is just overflowing the group, and then main code offset is effectively 128, and then it continues. And so in practice, that means that if you look at what we call the header group, we have the hash of the address plus the first 31 bytes of the offset that we hash, and we take the first 31 bytes that gives us the what we call the extension stem and extension node. I forgot exactly. And then from this node, it has 256 children. And the first one is the basic data. The second one is the code hash. Then there's the reserve stuff. Then you have the first slot all the way to slot number 63. And then you start with the first chunk of code all the way to 127. And everything else overflows to a different, like if you have more code or if you have more storage, it will overflow to different groups, which will keep the same address, but will have an offset that overflows the first byte. So the offset value here will change, and so you will find yourself at a different node, and then you will start writing. What are the advantages and inconvenience of this approach? Is that the biggest advantage and the reason why it was created is that it's quite compact. If you have a small contract with only a few slots that are just at the beginning and the beginning of the address space and not too much code, you will find yourself that you will find everything is in a single tree node. But of course, if it goes beyond that, it will expand to different tree nodes. The cons is that clearly the code is duplicated, because if you have the same code deployed multiple times in multiple accounts, this part, like from C0 to C127 potentially, this will be duplicated. So what we wanted to propose is that we just go over, we just move the code. So we try to deduplicate the code basically, and we create this main code offset that is no longer 128, but something a bit larger. And so all the code chunks will be in a specific group and not partially merged in with what we call the header group, so that it can be deduplicated. So we reserve, like, whatever we freed from the code, we put it in the header group. Like we use storage slots to the offsets we freed in the header group for the main from the code, we use it for storage instead. So instead of having 64 the 64 first storage slot, we get the first 192, and then we continue the the technique of overflowing to a different storage offset. But the code, yeah, like I said, is moved to its own thing. So if you look at what it looks like, you still have the address of the offset, which for the first 256 chunks will be 0. I think no, okay. But yeah, you only have storage slots instead of having code, and the code itself. There's a mistake. Like I said, there will be a mistake. So instead of being the address, you remove the address part. So sorry about that. This is wrong. You just have the chunk offset, and actually it should be the code hash. And then if you have the code hash instead of the address and the chunk offset, that gives you a new entry in the tree where you have everything, all the code you want. So there's a few issues. So as I was working on this, I discovered there's actually quite a bunch of issues with this. The first one is that yes, the code is deduplicated, but that means you have to create an extra tree node in any case. And as it turns out, taking Hans' measurements, you can see that actually the vast majority of contracts actually have a very small amount of code, which means that in the vast majority, it would fit into the account header. So we would be expanding the amount of tree nodes at the cost of deduplication. The other problem is that yes, if you got like the moment you need an extra tree node is shifted by 128. So not only do you always need an extra tree node, but on top of that, you will need a new one much sooner. And like I said, it's the same picture. Even those accounts will overflow to a different tree node. So even though there's not that many of them, this use case will be problematic. There's also, and I think that's the last one, 7702 that would force you to create one extra group for a single slot. And the reason for this is because you would need to just like there's only one code chunk which is 23 bytes, and you would have to create an extra group. So I was thinking you could make an exception for these, but if you start making exceptions, you might end up going back to the first model anyway. The other advantage, and yeah, okay, I'm sorry that the picture doesn't display entirely on the screen. But the idea is that there's actually a lot of duplicated code. So ultimately, there might be a benefit. Unfortunately, because of Devconnect and all those things, I did not quite measure it yet. So there will be a follow-up. But yeah, so I was actually thinking of mitigations. If you only store the stem and the commitment, so basically you don't store the code inside the tree. Like inside the database. Of course, the code is stored in the tree, but you don't store it inside the database. You could mitigate this, but I'm not sure it's really going to be impactful because you still have to store the stem and the commitment, and that's going to be quite. I mean, that's going to be taking some space. But yeah, and you can even make the same technique, apply the same technique to the current approach. And if this works for the other approach, this work for the current one. So we should be how do you call that? We should be I mean, they should be neutral basically. So there's no mitigation that doesn't benefit the status quo. And so my conclusion that unfortunately I didn't have the time, but I need to do measurements and find out what is the final size. Ultimately, this could be attacked if you keep deploying more contracts with the same code. So even measurements are only going to inform us as to what the current state of like what would be the benefit of the current approach versus the current implementation of the current implementation. Sorry, what would be the benefit of the current version of the translated state versus the proposed version, proposed current version of the translated state. Sorry, I apologize. It's still jet lag. Yeah, okay. So what I mean is, yeah, we would have to make a translation in both using both algorithm and see which one is the best. But it's going to only be a translation of the current state, and if we don't like, they could be attacked, and we would have to think about this. But ultimately, currently, although I would like to know people's opinions, if there are some. Unfortunately, Karim is not here, and Tanishq is no longer working on Nethermind. So I would like to know your opinion, but I guess it's not worth it. But we have to make sure. And like I was saying, it might be interesting to explore if we don't store the node, the code inside the tree itself. That might save a bit of the database, but that's going to be even more productive in terms of the current proposal. So yeah, ultimately, after considering it, I don't think it's a good approach. But yeah, I'm happy to hear dissenting opinions if there are some.
So what was the reason initially for the current status quo in the MPP is that code is stored, locally in client databases. It's not part of the tree, but only the code hash is and code size. My understanding is the whole reason for moving to a state tree where we have the code was for statelessness. Right.
Right. So there's the code itself. Putting it in the tree, that's for statelessness. But the reason why everything was merged together, that was a portal network consideration. And the idea was that if you're going to have to download your stuff from the network, you might want to be able to download the minimal set in one go to be able to start somewhat executing, or at least do something about the account, with the account, sorry, before you, or at least while you download the rest of the code. So that was like trying to increase the locality of the contract. Now, unfortunately, we no longer really have any effort maintaining the portal network. And anyway, I don't think you would be able to, even if it was there, I don't think it's such a great improvement anyway, because you would have to download everything. Because if, and that's typically the case, if your contract is a jump table that says, the prologue of most solidity contracts is getting the input data, which is a function hash. Use that to go through a big switch case and then jump somewhere else. So the benefits of having local contracts is only very limited to those contracts that are very, very small, of which there are many. But yeah, they're probably not the most popular either, from Hans' analysis. So I think, yeah, like I said, I changed my mind on that, but I don't think it was a very good. It was an interesting. I mean, it was an interesting design, but it also creates a lot of complexity in the code, because you always have to check, oh wait, am I lower than 128 chunks? If I am, then I have this special processing step. Otherwise, I do the other processing step, but I have to shift everything by 128. So ultimately, there were good reasons to do it, but yeah, it's not I'm not convinced. Let me put it this way.
Yeah. It's good to rethink it. That clears things up. Like if we made these decisions based on assumptions that are no longer true, then it makes sense to kind of rethink it a little bit. Yeah, I think it's worth having maybe some of the others in that discussion. But what do we want to make a decision? Like, what additional data would help us make that decision?
Yeah, so I think, and like I said, I'm sorry, I should have made measurements, and I hope to have them for next time. But yeah, like what we need to know is try both approaches and see what makes the bigger tree. And I think if one of the trees is significantly bigger, then we just need to drop the whole thing. Like we just need to go for this. But like I tried to say, and once again, I fumbled my explanation a bit. But I think if it's attackable. So anyway, we can't just make a decision based on what a simple translation was or is. We have to see how much it costs to go over the limit and make the other model more interesting.
Yeah, good. Yeah, thanks for presenting. Maybe someone else wants to chime in. All right, then. Yeah, Guillaume, were you going to say something?
No, I was just going to say, I don't know if you hear the beeps, but it's Karim inviting me, but he's not working today. So yeah, I guess we will share the presentation recording and see if we can get some feedback offline. But yeah, I think
yeah, we can keep that conversation going async or during other calls. The good. So I think that's it for this step of the agenda. I have a third step that I had noted, so I'll just go through it. It's a fairly simple thing. So Devconnect happened 2 weeks ago. This was an opportunity to get in touch with more, app layer teams, tooling teams, infrastructure teams. I wasn't there myself, but I know that some of the team has had the opportunity to get in touch with some of these people. Initially, our goal was to create points of communication with as many relevant teams as possible. The suggestion was to do Telegram groups with all of these teams. Now, I think what we're aiming to gain from these is like insights into how people use the state, how they consume it, and what compromises they'd be able to accept in terms of like state expiry, what that would look like, and the economics of it, the incentive mechanisms. I think it's going to duplicate a lot of effort if we create individual channels because we're aiming for the same feedback from all of these teams. And I don't see any downsides from just creating a general, like external teams Telegram group where our team can interface with all of these teams at once, share progress that is relevant for us and get feedback there. And maybe like these teams can also interact with each other. I don't think that's an issue, and it's going to be so much more manageable than creating like 15 different channels. Yeah, curious what you think, Guillaume, or some others. I have already shared that in the chat, but wanted to get people's feedback.
I mean, happy to have a single channel. More channels, what is it? Every time a new angel is a new channel is created, an angel dies. So
Yeah. We're aiming to kill just one and not 15. Yeah, that's fair. That's fair enough. Cool. So I'll try to round up a couple of the teams. I don't want to create the channel and just have like one team on it, but once I have like a threshold of maybe 5 to 10 different teams, all with like DMs and all that, all create the channel and have them join. Aiming for a few dApps, a few tooling, and a few like more general infrastructure or whatever. So, yep, I'll follow up, hoping to have that live like definitely before Christmas. Oh yeah, for the next call in 2 weeks. Still only 1st of December. So, yep, that's it for my particular point. So I might just give everyone 30 minutes of their time back, unless someone would like to take this opportunity and use the call for another pending question. Oh, I see in the chat, Mario had a question for Carlos, just asking whether you found any issues or blockers with East.
None. For now, we are completely fine. So that should be mostly it at the moment. Thank you for checking in, Mario.
Yeah, please reach out if you find anything. We are revamping the execute command at the moment, so I think there's going to be some changes. I hope we don't break any of your workflows, but I'll keep you updated if there's something from your end that needs to be done. Yep.
Okay. I assure. I mean, from Nethermind, Camille ran the state tests, I think yesterday, and everything went well. Anyways, if something needs to be refactored, ping me, because I'm refactoring some benchmarks to be compliant with the transaction gas limit cap introduced in Fusaka. So I will be already doing this job anyway. So it's fine if there's something else to do.
Yeah, if you need some review, I think this refactoring of the 16 million gas cap is going to affect a lot of the tests. So if you need, I would like for us to have like the same solution for all the tests. So if you can send me a PR or maybe send it to Luis also, and we can take a look just to make sure that we're basically doing the same approach for the tests. Yep.
I did some work for Spammer, and I sent it to Luis. The idea is to wait for Luis to actually check it and see if we go with that or if he plans to do something else so that we don't duplicate work.
All right. Yeah, for Spammer in particular, I would also reach out to PK from Pandops. He's the mastermind behind.
Yeah, it's merged already. So with PK, everything was sorted out, and we are already bloating ERC20s with the Fusaka limit and the solution that I implemented. But I don't know if that's what we want to have in EELS. So yeah, just waiting to hear from Louis, and from there we can move forward.
Sounds good. Thank you.
Perfect. Yeah, thanks, guys. Yeah, so I think that's it for this call. Yeah, thanks everyone for joining. I'll be Guillaume, were you going to say something?
Yeah, sorry, just a very quick thing. Mario, I will be writing you to talk about, try to finish our conversation from Devconnect, see if we can get something started to have binary trees with the new welded execution spec.
Sounds good. I think, are you in the Steel Discord server?
The Discord server? No. I can
Still.
be in Mattermost. Okay.
I can send you.
Please.
I can send you an invite. So what we can do is maybe start a channel there, because all of the EELS team members are there. So we can tag them, and then we can start the discussion. But we do have something in Mattermost, right? Is this?
We have something in Mattermost, but if we do it in Discord, we could actually get Karim as well, which I'm sure would be interested.
All right. Okay. Good. I'll send you an invite. Yep.
Good. Thanks, everyone. That's it for this call. We'll be posting a summary of this call in the Stateless book and tweet probably this week. So thanks. Have a good rest of the week.
Thank you. Take care. Bye.